Hey, what's up, Algebra 2? Here we are with 2.3, rate of change and slope. Okay, the rate of change is defined as a ratio that compares how much one quantity changes compared to another quantity. All right, our biggest one that we know is slope. All right, change in y divided by change in x. All right, sometimes you'll see it written as delta y over delta x. Okay, your slope formula, y2 minus y1 over x2 minus x1. Or if we're looking at it graphically, sometimes we talk about it rise over run. Okay, so just a quick review. Finding the slope between 2 points, y2 minus y1, x2 minus x1. Remember, it doesn't matter which one you label, x1, y1, x2, y2. I could flip that around, x2, y2, x1, y1. All right, either way, it's going to be fine. So y2, I'm going to go -1 minus -4. A lot of negative signs up there. That can be tricky. x2 is 12 minus 3. So -1 minus a negative is going to be a plus. So we have -1 plus 4. That's actually going to be a positive 3 on the top. 12 minus 3 is 9 on the bottom. And our slope for this should be 1/3. Okay, why don't you hit pause here in a second and try the next one on your own. Go ahead and hit pause and try this one on your own. Ready, set, go. All right, welcome back. Let's see how you did. Okay, y2. You know what? Just to kind of show you that it goes the other way, too, we can go 3 minus 5. Let's do it the backwards way. So this is now my x2, y2, and this is going to be my x1, y1. It doesn't matter which one you label as point 1 and point 2, just as long as you don't mix and match. Okay, so we got 3 minus 5, -4 minus 2. So across the top, 3 minus 5 is going to be -2. -4 minus 2 more is going to be -6. Okay, and that's going to reduce to a positive 1/3 again. Okay, if you went the other way around, I'm going to guess you had a +2 and a +6, and a +2 and a +6 is still going to reduce to a positive 1/3, just like we had here. All right, so there you go. It's math magic. Okay, here's a bit of a thinking problem. They're going to give you 1 point and half of the other point, and they're going to tell you the slope, and you got to come up with what the missing point was. Okay? So this is going to come out a little bit cleaner if this one's in front. So it's going to be y minus 3 over 5 minus 1, and that's going to equal 3 or 3 over 1. Didn't leave myself much room here, did I? Okay, so 5 minus 1, that's going to be a 4 on the bottom. Okay, we don't want a 4 on the bottom. We're trying to solve, so we're going to multiply by 4. And now we got y minus 3 equals 12. Add that 3 over. And now y is 15. So if this was 5, 15, my slope would work out to be 3. Okay, 15 minus 3 is going to be 12 on the top. 5 minus 1, we already have that. 4 on the bottom. 12 divided by 4. Should give me a slope of 3. Perfect. All right, finding the slope from an already graphed line. This is where you can use rise over run. You can also just look at the coordinates of the points and do the slope formula again. I'll try to zoom in here. I'm looking at this up there on the screen in the front of the room, and it's kind of tough to follow all these. So let's see here. So we could just do the points. Yeah, these cross lines aren't the darkest, are they? 1 comma negative 2. And what is that? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. All right, we got 1 comma negative 2 and 4 comma 7. And you could go through into the slope formula again. All right, but if you remember back up to here, all right, we have change in y over change in x, which we did y2 minus y1 over x2 minus x1. It's also rise over run. So as you look at your line, reading it left to right, no matter if it's going up or going down, you read it left to right. What's the rise? 1, 2, 3, 4, 5, 6, 7, 8, 9 up. And 1, 2, 3 is my run out. So rise over run, we went up, so that's a positive 9. Always to the right, out 3. And my slope should be 3. Let's see, if I did y2 minus y1, 7 minus a negative 2, minus a negative is going to be a plus. So that's actually going to be plus 2. It's going to be 9 on the top, which is what we have. 4 minus 1, 3. 9 divided by 3 is 3. So it works out. Okay, I'm going to try to get this in here so you can see this other one. Okay, I know it's tough to kind of look at it on the screen there. That's as far as I can get it zoomed in. And yeah, that's as far as it's letting me go. So why don't you try this one on your own. See if you can follow along those grid lines. Just do the best you can. Give you about 10 seconds here to count that out. Rise over run. Hint, it's not rising, so it's going to be negative. It's actually going down. Okay, let's see what we got. So actually here, we're going down 1, 2, 3, 4. So I went down 4, so I'm going to call that a negative 4. And I went out 1, 2, 3, 4, 5, 6, 7, 8. Always to the right 8. So your out, when you're doing this method, is always going to be positive. Okay, so this is down 4, out 8. Negative 4 over 8. Our slope should be negative 1/2. And you can double check that with your slope formula if you'd like. That's negative 1, 2, negative 4, comma, 1, 2, 3, 4. Negative 4, comma, positive 4. And that's going to be 4, comma, 0. Okay, zoom out, back to normal here. Okay, sometimes they're just going to give you the equation already. It's going to be some form of an equation, and you need to find the slope. Okay, well, remember that we have slope-intercept form, y equals mx plus b. I use a capital B on mine because my little b ends up looking like a 6, and I get lost and make mistakes. So when I do plus b, I use a capital B. Don't feel like you have to. If you have nice handwriting and you can clearly tell the difference between your little b and a 6, then go right ahead. So if they give you an equation and they want to know the slope, the easiest way for me is just put it in a slope-intercept form. Get y equals. Okay, get y by itself. Whatever's touching x is your slope. So this one's pretty easy. All right, just divide everything by 6. Okay, so we got y equals 8 over 6 would reduce to 4/3 x. This isn't going to really matter. Let's see, 36 would make it negative 6. We'd have 4/6 left over, or 2/3. Okay. That doesn't really matter. Well, all we're looking for, find the slope. The slope is 4/3. Okay. Same idea over here for you. Let's see if I can get both of them on the screen. I get both of them on the screen. There we go. Same idea over here for you. Maybe a couple extra steps because it's not quite as nice as the one I did. Okay, but same idea. Get y by itself, get it into slope-intercept form. All right, and then that would be your slope. All right, so go ahead and push pause and try that on your own. Okay, welcome back. Let's see how you did. All right, I'm trying to get y by itself. Well, we'll just do this. Minus 12. I'll try to use the red pen here for the steps so you can see that. So we got 3x minus 12 equals 2y. Divide everything by 2. So we got 3/2 x. That's what I want. That's going to be the thing that matters the most to me right now because that's the question. And if that's bothering you, you can just totally flip it. Y equals 3/2 x minus 6. It's the same. There it is. My slope is 3/2. Or 1.5 if you are a decimal person. That's fine with me. Okay. Hopefully you're able to get that. If not, watch it back. See, maybe I made a mistake. Or see where you made your mistake. Okay, and then like a, oops, sorry, stuck to my finger there. Like a story type problem here. Pretty similar to one I think you might have in your homework. Various times in the day. I think they're spread out over 4-hour increments. 6 a.m. at 4 hours. Noon would be 2 hours, and then to 2 would be another 4. Yep, 4 hours, 4 hours, 4 hours. So 4-hour increments. Temperature is in the day. Looks like a nice fall day. Or early spring, I guess. So what would be the slope? And if you see a table like this, guys, the top is usually x, bottom is usually y. Or if you're dealing with a situation where it involves time of day, time is always like 99.99% time is going to be the x. Okay? So, our slope from 6 a.m. to 10 a.m. Alright, so we have 10 a.m. and 6 a.m. So we had, this is our 0.2, so let's go 54 minus 50, and then 10 minus 6. So we went up 4 degrees over a period of 4 hours. So our slope would be 1 degree per hour. Okay, what about from 2 p.m. to 6 p.m.? Be careful, we skipped the 10 a.m. to 2 p.m. window there. What about 2 p.m. to 6 p.m.? Alright, so on the top we got 58 degrees minus 58 degrees over 6 minus 2. So we changed, over that 4-hour span, we did not change our temperature. So the slope would have actually been 0. Okay, that's just looking at that 4-hour range. You know, maybe at like 4 p.m. there in the middle, it was actually 60. Maybe it did continue and then it started going down. But we're just looking at that endpoint to that endpoint. It's going to be flat across. Okay, and then our last one, same idea here. Why don't you give that a shot? Why don't you give that a try? Push pause and you guys can try 6 p.m. to 10 p.m. Okay, let's see how you did there with that. So at 10 p.m. we had 54 degrees. 6 p.m. we were at 58. 10 minus 6, so we have a negative 4 on the top, a positive 4 on the bottom. And we can tell we're going down in temperature now, so that makes sense that our slope is negative 1 degrees per hour, negative 1. All right, there it is, guys. Hopefully that's a nice little review on slope for you, and just a couple different ways to use it. All right, those are all the types of problems that you'll be seeing there. Whether it's slope between points, here's a point, here's half of a point, and there's your actual slope. Find out what the missing coordinate would be. It's a good algebra type problem. slope from a given line, from a graph. They might not be as nice and put like solid dots where the 2 points are, so you might have to just kind of find some nice points on your own. Slope from an equation that's not already in mx plus b form, kind of switch it into that. And then like a story type problem with a chart maybe. Okay? Thanks for watching, guys. Good luck. Let me know if you have any questions.